Hi everyone, welcome back to CS410J Advanced Java Programming at PSU. Week 2, Electric Boogaloo. No, not really. It's so great to see so many of you back again. I just want to start off by thanking to everyone who participated in the Google Plus community. It's great to see so much conversation over the last week. There were some really good questions on there. And if you haven't signed up yet, if you're not participating or at least watching, I encourage you to do so because there's a lot of good information that's coming from your peers. I wanted to start off class to open it up to questions that you might have, sort of any things that you've thought about over last time. What can I tell you? What have you learned? Anything? Yes.
Which school computers were it that you had to install Java 1.8 on? I could only find ones with 1.6.
So it's the CAT computers, the engineering schools, and so the Solaris machines, which are like cs.pdx.edu, I think that's Chandra, and then the Linux systems, which are the linux.cecs.pdx.edu. Yep, those guys should all have Java 8, and if they don't, let me know. Sorry, what? And you have to, yeah, that's right. You need to do the add package command, which I think we saw last time. So, cool. If people started, I think, well, we certainly saw on the list, people started the assignments. If people going through the cones, has everybody at least sort of gotten the environment to run a cone so far? Yeah, I'm seeing lots of nods. So, yep, okay, good deal. Excellent, all good there. Okay. Anything else before we get started? Did you want to talk about Java 6 now?
Yeah.
Or Java 8?
I'm running Snow Leopard. I don't know if anybody else is, and you can have Java 8 on Snow Leopard, so I just wondering if anybody else is in that similar position.
Yeah, I know last week we were talking, a couple people said, oh, I'm running, some either older or, a distribution of Linux that doesn't have, the latest Maven and the latest Java. Is anybody still in that situation? Yes?
Well, I had your.
I'm sorry. You can sign.
But it works fine.
Okay.
Like the Java 8, if you download the SDK like tar, you should be able to run as it is. You don't have to compile it.
Well, I think Smith's experience was the same as mine when I had an old machine that had Snow Leopard on it. That the DMG itself, required that version of the.
You have to use the DMG and you just or.
I don't think Sun releases a. Oh, maybe they do. Well, let's go check. I always thought it was the DMG.
The same thing with the Maven. I installed that
right.
Manually, and it just works right out of the box.
So let's see here. Oh, Mac help. Where's the download page?
I want to look for the Java SDK.
Yeah. That looks good. And then let's see here. Yep, SE8. Oh yeah, there we go. Download. What do we got? Mac OS X. That's a DMG. I think all Sun supports is the DMG. So that being said, Smith and I were talking about it, and strictly speaking, there's nothing that requires Java 8. As a matter of fact, probably everything will work with Java 6. And Java 8 is still pretty new. For the benefit of those of you that can't, install all the latest stuff, I'm okay with. I'll just change my the build to just have Java 6 level bytecode, and that should be okay. I think it might mean that some of you might need to download some different artifacts, maybe. But I think as long as your rule of thumb is make sure it works on the CS machines, because that's where I'll be grading it. Everything should be okay.
Why do you choose that machine out of some of the newer ones that we have?
Sorry, what?
Why do you choose the Chandra, for example, compared to some of the newer ones that we have?
There are newer Solaris machines?
Not Solaris, but
they're
Linux.
I've always used Solaris.
It's not going to be around that much longer.
It's been around for 14 years, and so. But yes, at some point, often they can pull it from my cold dead. I don't need it. Just in time upgrading. Listen, I'd rather be making new lectures than trying to figure out. But yes, I could do it on Linux machines. Yeah.
Were you still playing allowing the older versions of Maven, like the earlier 3 version?
Yeah, I think that would be okay. So like the 3.0, I think
3.0, yeah.
3.04 or something like that. Yeah, so I'll do that. I might even do it during break or something. Okay, good deal. So yes, so that should let everybody get off the ground, even if you're running an older version of Java. And yep, I'll just do all of my Java development off in a branch in GitHub. Sorry, my Java 8 stuff off in a branch in GitHub, and worry about it later. Okay, good deal. Anything else before we start talking about what we're doing today? No? Okay. So let's go to the agenda. So here in week 2, I hope you all took the opportunity to review the lecture materials for the Core Languages API. A lot of stuff there. We broke the screencast into 2 sections. Any questions on that? Is that stuff familiar? I mean, have you guys covered things like the how to do I/O and some of the language stuff like string builder versus string buffer and stuff like that in other courses? Yeah, a little bit, some of it. Okay, basic stuff. So like what we'll be doing here in class will not be a review of that. Someone's asking me about it at office hours, and like the coding that we'll do together, or that tonight I'll do in front of you, and then we'll be doing going forward, won't necessarily touch on every part, everything that we cover in those lecture notes. And so I'm going to be relying on you guys to ask questions either in class if you have them here, or on the community as you see them. So the lecture notes are there, so you don't have to listen to me live. So we can spend our class time focusing on what it looks like to write clean code using good software craftsmanship principles. So be sure to do that. What I do want to cover tonight, though, is some more sort of structural things about the class, mechanics of how I'd like you to document your projects, and then show you how to submit your projects, because your first project is due next week. Then we'll talk about the second project, which uses some of the stuff that you learned about in the Core Language APIs lecture. And then what we'll also start tonight, you'll be watching me complete the student example that we started last week. Unfortunately, the grader, Dave, is ill and couldn't make it tonight, which I'm kind of bummed about because we were going to pair program. We're going to do this whole thing, but I guess you watch me pair by myself, which will be weird. So I'll be pairing with all of you because I'll be asking you for some help and some guidance on where you need to go. And we've got a couple other references there. So anyway, so that's the outline tonight. So let's dive right in and talk about how to document your projects. Okay. So especially as you're more of a more junior developer, being able to document your code and explain what it is that you're doing and why and how in English is important. It helps you organize your thoughts and helps you convey them. That being said, as we'll see, part of the documentation is are the names of your classes and your methods and your variables and things like that. So if you have a well-documented and well-thought-out design, it makes it easier to program, and it also helps you do things right the first time. And also helps you evolve your code as it's used by other people and as you use it more. So we're going to be seeing a lot of code here, and you're going to be writing a lot of code. And so I have 2 mechanisms that I'd like you to use to document it. The first is the plan of attack. There were a couple questions about this on the forum over last week, and here's what it's all about. So each project, there is something called a POA, a plan of attack, that I'd like you to submit to me via email before it's due. So the whole idea is that I want you to just write me 2 to 4 paragraphs, so don't give me code or pseudocode or whatever, just in English. It describes how you'll implement the project, what the pieces parts are, how they interact. And this is worth 1 point of your project grade. So project 1 was worth whatever, 9 points or something. 8 of those are for the code, and 1 of them is the POA. Now the POA is due 72 hours before the project is due. So that's Sunday night at 6 p.m. And you don't get late days to use on the POA. So I want everybody to start early. Please email it to me. and put the letters POA in the subject. I have an email filter that will filter them all into a special directory. And so this means that if you've got something important to send to me in an email, don't put POA in the title. I've had that happen a couple of times where it's like, oh, I won't be there in class, POA, and I don't see it until 3 weeks later. So blah 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 blah. Oh yeah, and there's if you submit the POA late, there's no credit for it. So the method to my madness here is that the POA not only makes you think about your code and describe it in English, but it makes you think about it early. So I think a lot of this is to really force you to get your project straight in your head, get your questions answered, figure out what you're going to do, your plan of attack, before the last minute. So, I'm evil. Okay. Any questions on the POA? Not a big deal, but something that's important and is worth 1 point of your grade. As we saw last week, Java has this facility called JavaDoc. There are these special comments that you can put before things like class declarations, method declarations, field declarations that describe the program. Oh, yeah, sorry, question? Yeah.
Sorry, for the plan of attack, do you want it just in email, or do you want a text attachment?
My preference would be just an email. Body of the email. Don't attach a Microsoft Word document or I use OpenOffice from 1998. Please just text an email. All right, thanks. Yeah, good deal. I want to encourage you, as a matter of fact, I'm requiring that you write JavaDoc for the code that you author. And this is laid out more in the lectures, and we'll see some more of it tonight. And of course, feel free to ask questions about it. But what I'll do as one of the things that I grade you on is that I'll run a tool that will extract the JavaDoc and print out the comments that you have. And based on that, I will give you some. Let's see here. I think I say up to 1 point. Well, I think it varies by assignment. But part of your project grade is the thoroughness of your documentation. Really, what I expect is for a method, like a 1-sentence description of that method, and then each parameter should be documented. The return type of the method, if there is one, the return value of the method, if there is one, should be documented. What exceptions can be thrown, et cetera, et cetera. You can find more about JavaDoc at this URL. Also, this isn't something I'm necessarily going to grade, but what I recommend is that you take a look at the standard Java coding conventions that Google has put together. This sort of captures what most Java developers do. What I've found is that following a style guide like this one will make your code more easy to read by others. And then also, as you read others' code that if you use these same kind of style guidelines, you'll be able to read it more easily. And so I try to conform to these guidelines in my own code. So it's something to read over. And then finally, as some of you noticed, there's a -readme option in your assignments. And so the -readme is a little piece of functionality that that's part of your projects that prints out a brief description of what your project does. It's like a 1 paragraph. Here's what it does. The README should include your name and the name of the assignment. And it's not just the command line usage, although it can have the command line usage, but also here again, it's about explaining in English what it is that your program does. And note that when the -readme switch is specified, your program shouldn't do any other work, so no more error checking. So and that includes parsing the command line, which I think was a question that was raised on the community last week. So when you say when your program sees -readme, print the README and exit, and that's all you need to do. I think that's it. Yep, and that's it. So a couple of requirements for documentation: the plan of attack, the JavaDoc comments, and the README. Any questions on that? Yeah. Good deal. Okay, great. So now you've done all this work to write your code, and you've got all your test passing, you've got all the documentation, and now you need to submit it to me. Way long time ago, there is an API called Java Mail, which is a Java API for sending mail over SMTP or whatever. And I wanted to learn about this API, so I wrote a program that you guys use to submit your files to the grader. It's in a class called submit, and when you run it, and you run it like this, it requires some options. Well, it asks you to, you provide it information about the project that you're submitting. So basically, what you do is you say, hey, here's what project I'm submitting. Here's who I am. So your name, your login ID, your email address, so I know who it came from. Anyway, and then one or more files to submit. So for your first assignment, you'll have at least 3 files to submit: the project 1, and then the airline and the flight. And you put all those on the command line. Here's an example down here. So let's say I was submitting project 0, which is just my, well, in this case, just project0.java. I would run it, put the grader on the class path. Here's the main class here, submit. And then the arguments are project 0, the name of the project. Here's who I am, my login ID, my email address. And you can also have options like comment. So things like, oh, hey, I'm a little late, or whatever, you can have it there. And then the names of the files to submit. And so what this does is it takes all your source code, it creates a jar file from it, attaches it to an email, sends it off to the emails, it sends it off to the grader email, and then I have a program that uses Java Mail to extract all those submissions, puts them in a directory, updates my little gradebook program, and away we go. And so this, I think is easier. Well, so I don't know if it's easier for you, but sure it's a lot easier for me to have all of the source code come in sort of like as a jar file that and actually it's Dave the grader who will then unzip it and grade it. Make sense? Okay. Yeah.
So it must be run from one of those Slayer's machines.
Yes, it'll work best. I think it's possible to use some other SMTP server or whatever, but where I have tested it and where I feel very confident it'll work is from the CS machines. So yeah, so I recommend the workflow. Develop on your own machine, and here again I encourage you to use GitHub to store your stuff off to a private repository. Then on the CS machines, make a clone of the GitHub repository, get your latest code, test it out there, make sure everything works, and then use the submit program to submit it. Cool. Any other questions?
Is there any reason why it wouldn't run on Slayer's machine?
It does run on the, why it wouldn't run?
Why it would work on ours and not theirs? Why it would work on our machine and not work on the
Oh no, I've only tested it on, or rather, I support it on
the
the.
case where it won't run on the CS machines, but it'll run on the
No.
computer. Okay.
No, I haven't. But I don't think I don't think I have too many examples of people trying to run it on their own machine, because you need to have an SMTP server that you.
No, I'm talking
Oh,
about
to the
our
project?
Our
No.
projects.
I mean, I can't think of someone that truly was like, oh, it worked on my machine, and then I copied over exactly and it didn't work. But I guess I say that just because you never know. More likely, where I find people have problems is that when they copied it over, oh, they forgot to copy a file, or they made some modification, didn't realize something got blown away. So here again, if you're using GitHub, it's much less likely to do that, to have that happen. Okay, stunned silence. So exciting. Okay, so documenting your files, submitting your programs. I want to come back to the next assignment because I want to write some code. So let's watch a video. So let's see here. So I mentioned it last time. Let's pause this here. How many of you guys have heard of Agile software development? Everybody, great. Extreme programming? Okay. So in the last 15, 20 years, there's been a real change in mindset in terms of how software is developed. As as the internet came into its own, as the mechanism by which software gets to its users has changed, it's resulted in our ability to do things that we just couldn't do 40 years ago, especially around the turnaround time on things. So, think about how you got software when you were running like Windows 3.1, right? You went to a store and you purchased a box, and inside that box was a floppy disk that had a version of the software, and you put it into your computer and you installed it, and that was that. Maybe there was an update that you had to go back to the store and buy and install, right? Very cumbersome. Now, today, it either updates itself automatically, or you go to the App Store and say, it tells you that there's a new update. You go to the App Store and you download it. Because of this rapid feedback, people now expect bugs to get fixed immediately. As soon as a new feature is ready, you can put it out there and have everybody use it. But in order to accomplish that, you need to have a couple of things. You need to have you need to be sure of the quality of your product. And a good way to assure the quality of your product is to have automated tests. And we saw a little bit of that last time with test-driven development. Another thing that you need is that you need to be able to have engineers that really know the code and that are really familiar with working in their environment. And software developers have found that it's really hard to, that it takes a team of people to develop code. And it's not just, a team of people develop software. And it's not just coders. So yes, you need someone to write the code, but you also need someone who is, expertise and who thinks about how to test the code, how to test the code at scale, how to test the code under unusual conditions. You also need someone who is your user or who represents your user, right, to figure out what needs to be done, what will get the best benefit, who is your customer, what do they need, what will make them happy. This has sort of evolved into agile software development, where we have methodologies and we have tools and we have processes that encourage visibility into what the user needs, that enables continuous deployment of new code, new features, getting them out into the hands of people quickly. And another thing that extreme programming really popularized and introduced is the concept of pair programming. So that when you're thinking about a problem, one brain is good, but two brains are better. And so we're going to start off by looking at a pretty cheesy, but nonetheless accurate and valuable video from people at North Carolina State University talking about pair programming. So here again, I warn you that it is pretty cheesy, but it speaks the truth. So let's get going here.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver, who actively types at the computer or records a design, and a navigator, who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds a record. Oh,
right.
Probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
why do so many thousands of students around the world prefer pair programming? Why don't we ask some? to compare
Yeah.
old-fashioned solo programming to this new and innovative system.
Wait, what was the order?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against the desk and trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with two people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen, too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation, too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy. There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Okay, that's I got 45 seconds of credit. So yes, admittedly cheesy, but let's talk about what they were saying. They're really saying two heads are better than one, and so we're going to let me turn on the buzzing. Starting next week, we're going to be doing some pair programming here in class. So I asked Warren, the department head, and he went out and got a bunch of USB keyboards, and I think we have enough for I think 20 pairs or something like that, and there are about 40 of you, so I think that should work out okay. And so next week, what we're going to do is we're going to start doing what are called coding katas, which are little programming assignments for us to do during class. And this is an experiment that I tried last year. I think it worked out pretty well because I want to get you guys working with each other to apply what you've known, what you've learned about Java, and then also learning what it's like to code with someone else there to coach you and to guide you and to navigate for you. So, like I said, like Dave the TA and I, we're going to demonstrate it tonight. We'll demonstrate it next week instead. But we will be seeing some test-driven development tonight, and that's what I want to start now. So, I'm sorry. Any questions about pair programming? Anybody ever done it before? Yeah? A couple people? What'd you think? What were your...
I love it.
You loved it? What do you like about it?
Well, I was paired at my internship with someone who was much, much more experienced.
Mm.
And, I mean, what they were saying about you can sit there and bang your head against a problem for hours and hours, or borrow some experience sitting right next to you, and being able to bounce ideas off of each other to solve the problems. It's much more collaborative, and you accomplish things much faster. Not just twice as fast because you have two people working on it, but it's kind of an exponential growth and productivity.
Cool. Anybody else? You said you'd done some too?
Yeah, I really enjoyed it. It was the same experience what he had. Just like, when you get stuck, you have someone else kind of sanity checking yourself and your work. Also, they can come up with, cool ideas
Right on. And you too?
Yes, I have not done a lot of like real pair programming, but it's something I've always wanted to try because I have lost track of the number of times I've come across a problem which I'm sure is intractable. This bug must be crazy complex, and then like within seconds of starting to explain it to someone the first time, oh, that's what the problem is. I mean, just talking with someone makes it so much easier.
Yeah, excellent. I think those are all the benefits. So we'll start experimenting with it next week. And yeah. Okay, so let's go back to that student project that we started last week. Remember this guy extending a class, and we had a simple student class, and we created the Maven archetype. We basically got it to got those first two tests passing. Well, I guess what I'd like to do for well, the remainder of class tonight, I don't know how long it's going to take, is to do some more coding with you guys to come up with to build this little student application. Over the well, I asked about on the here on the forum, I asked you guys to contribute some ideas for what could go wrong with it. Those of you who are online, if you've maybe thought of some more, please feel free to post them now. I think we can use this sort of as a starting point for our test-driven development. I want to open this up in its own frame. How do I do that? Oh yeah, discussion. One at a time. Yeah, that'll do it. I thought it'd be bigger. I was wrong. There we go. That's too big. Okay. Nice. Okay, I'm going to open up IntelliJ again. Slowly. Yeah. Okay, I'm going to go back to my student project. Okay, here's my student class. And did I know? Image, super awesome. I'll go back to my student test. So let's see here. It's been a while. I want to make sure that everything still runs. So I will run my student test. I'll invoke the two tests. It says that everything is passing. Super awesome. Okay, well, let's break some stuff. So I want to go to what you guys said. Let's see here. So David from Portland, Oregon writes, no. Okay, the number of command line arguments. What about the number of command line arguments we want to test? Where's David? Oh, there. Sorry. Yep. Okay. So let's see here. We'll have a test. So like what? Maybe too many command line arguments? Maybe not enough command line arguments. Okay. Not enough command line arguments. What happens when you don't have enough command line arguments? Okay, what should the program do when there are enough command line arguments? Okay. Should error. That's kind of similar to this one, right? I guess this is no command line arguments. So we already have a test for no command line arguments. How about we have one for maybe one command line argument? One command line arguments. And then prints missing command line arguments. Missing arguments to standard error. Okay. So we didn't go into a lot of details about the invoke main class last time. So let's talk about that, or the invoke main method last time. So let's see here. I don't think I have it. Oh, I do. Excellent. Okay. So it's looking off for the source code now where it wasn't before. So this is a class that I wrote. It's off in my package. It's called invoke main test case. And what it does is it provides a framework in which you can invoke a main method, and you can do things like call system.exit, and the VM doesn't actually exit. So it allows you to write unit tests by calling your main method. And so if you look at the signature of this method, it takes one argument, which is one of these instances of the class, which you learn about in detail in the reflection lecture. But the whole idea is that it's the name of your class that you want to test, the one with the main method, followed by .class. That refers to an object that represents a class itself. And then it's got a variable number of string arguments, which are the command line arguments, to send to the main method of that class. And it returns something called main method result, which has, let's see if we can find, it has an invoke method. Here, wait, I'll just do command F12. See that okay? Yeah. So here are the methods that it has. You can get the contents of standard error. You can get the exit code of the when system.exit was called from the main method. And you can also get the contents of standard out. So we want to test it with one command line argument. We're going to call invoke main. The name of the class is going to be student, so we're invoking the main method of student.class. And what should our one command line argument be? Fail. Okay. And when we and we're going to, let's see here, extract a variable called result. Sorry, let me do that again from the menu because you can't see what I'm typing. So one of the refactorings that's available to you in IntelliJ is to take an expression like this. Right, an expression is something that returns has a value, returns a value, and you can say refactor, and you can say extract variable from the highlighted expression. And I'll say, okay, great. It's going to create a variable, and it'll give you like some example names. You could also just type. Oops. You could also just type the name. I want to call mine result. Now you've got a variable there. Okay, so I go and I run my main program, and what should I expect to be written to standard out? Not enough command line arguments, okay? So let's see here. So let me, not enough, well, yeah, I'll just remember it. Okay, so the way I do that is I say, okay, I'm going to assert that the result.getError, so standard error, that what was written to standard error from invoking that main contains string. Oops, contains string. What was it? What was it again? Not enough command line arguments. So yes. So what was this assert that thing that you just did? So if you hover over this assert that method, it tells you that it's from this class called assert matcher assert, and that it takes a string and this matcher thing. What's all of this about? So one of the third-party libraries that I find to be really useful is something called Hamcrest. Hamcrest is an anagram of matchers, and what it does is as following. So if you guys watched the JUnit lecture, you saw that in JUnit they offer a bunch of methods that are like assert, so like assert equals. And so it's just like in the cones, right? Where you say, okay, I have an expected value and I want to assert that it's the same as, sorry, I have an actual value and I want to assert that it's the same as the expected value. And if it's not, I want it to fail. Well, JUnit has assert and assert equals. And that's cool, but they're kind of limited in some respects. And sort of the, they don't have things like what we see here, like the ability to say, okay, assert that some string contains a value. Some other guys that really like JUnit but want more when it comes to assertions, develop this library called Hamcrest. And basically, it provides a little domain-specific language that reads a little bit nicer than JUnit. So you can say things like, "Hey, assert that some object is equal to the object that I expect." And so I encourage you, and I'm pretty sure I cover some Hamcrest stuff in the JUnit lecture. I encourage you to use this this library in your own unit tests. And I believe the archetypes all use Hamcrest, and so it should be available to you. So it just has these assert that methods that read a little bit nicer. Okay, so let's run this test. says run this guy. I'll run it. And it failed. Another nice thing about Hamcrest is that it gives you nice error messages when things fail. It said expected, string containing not enough command line arguments, but was missing command line arguments. And so then if I go look at my main method, sure enough, I'll remove that debug line. Yep, all it does is prints missing command line arguments. So what do we want to do? How are we going to get this guy to pass?
Change either or to match the other.
Yep, that'd be one way to do it.
Check the number of arguments. Under a certain number. That here.
Okay, yeah, that's a good point. Yeah, right. So if there are 0 command line arguments, we should say missing command line arguments. If there's not enough, we could say not enough command line arguments. Okay. So let's see here. What do we need to do there? So the command line arguments dot length equals 0. Oops. Do that. Else, if args dot length, how many required arguments are there? 6. Not enough command line arguments. Okay. Okay. Let's run the code again. So this is the red. I'm Uncle Bob. Hey, look, we're green. Okay. What was the other color? That blue color. What did that mean? Right. Red, green refactor. Is there a way that we can refactor this code? I see some duplication here, right? I mean, I sort of see multiple calls to system.error.println. You can't really switch on like 0 and then less than 6. What was that?
You can store your strings.
Yep, we could put like do it in a variable. I've got an idea. I'm going to see if I can extract some of this logic into a method. So the first thing I'm going to do is extract a variable here. Oh, yeah, question? Yeah.
Just something I'm wondering. Do we, now that we have a case that checks to see if we have too few than the amount we need, do we really need to check if there is 0? Because wouldn't not enough command line arguments already let us know that we need command line arguments?
Yeah, that's a good point. Okay, so then, I see lots of nodding. What should we do then? And then just have it print. Okay, so like get rid of this. Get rid of that. Oh, oops. There you go. Okay, so run my test again. That guy passes. I think if we go back and run all of them, we'll see this thing fails, right? Okay, and so then, yep, okay, so then this should also be not enough command line arguments. Okay, nice. So now we're back to red. Run them all again. Yay, everything is passing. Okay. Yeah.
In practice, when having programs that take it command line arguments, would it be best just to show like a quick preview saying like this is the program and the arguments it takes? I mean,
yeah.
A lot of Unix programs give that when you don't give it enough.
I like that. Awesome. So let's write a test for that. Okay. When command, when arguments are missing, what happens? Usage message?
Like usage.
Usage message is printed to standard error. Okay. So let's see here. We're going to Let's just do like 0 arguments. Again, I'm just going to copy this. Oh, you know what? Shoot, I'm seeing duplicate code. I'm like that little kid in that M. Night Shyamalan movie. I see duplicate code. So how about...
If you want some inspiration,
Yeah.
like if you open a terminal and type P with no arguments, it'll show you, it should show you usage, like where the brackets mean optional and then at the end it's required.
Yeah, I'm inspired. Okay. So, see, it didn't say don't be snarky in the, yeah. Okay. And yes, I showered this morning. Okay, awesome. So I've got nothing there. So what should be written to, oops, sorry, a contain string. So like, what should our usage look like? Actually, is it in the assignment? Knowing, did I actually put that in the assignment? That's project 2. Oops. Did I? No.
Give an example on page 2.
Yeah. Okay, so no, I guess I don't really have an example of usage. Okay, so what should the usage look like?
The program name and
Yeah.
I guess Java-jar program name.
This is kind of what it looks like in your other assignments, so we'll just do it here. And then student, and then let's see here. What are the command line arguments? Okay, so name, gender, GPA, and then classes or class.
You put, like, if you put classes like in quotations, that'll
Like this?
Yeah.
Oh, okay. I was just gonna put class star, but that works. Oh. Yeah. Cool. Okay. So there's usage. Okay. So let's run it. Okay. Blew up. Good. So red. Let's make it green. What are the quotation marks for?
To know that you can have multiple like words. I guess
Oh.
how you.
Yeah. I've always used just star.
I guess it's implied then that if you have spaces in your arguments.
Oh, like that. Yeah, yeah. I mean, so it's the whole like you're talking about like if you have, because actually, according to the assignment,
There's operating systems that have,
right.
That's one class, but it has
Yep.
spaces. So I guess the quotations could be implied.
I usually imply the quotation is just like how Unix works. When you have a string in in double quotes, that's one command line argument. But no, I see. Cool. Okay, so here's our usage string. And so let's see here. I'm going to, here's what I'm going to do. I'm going to copy this over here so that we can then put it like that. And then system.error.println, empty line, and then system.error.println, and then our usage string. Like that. Okay. Now let's run it. Yay, green. Okay, refactor. Any refactorings do you guys see? In main? Yes, I concur. Look, we've got invoke main, we've got this whole like result and get error and things like that over and over again. How about we do the following? Yeah. So what do you suggest for refactoring?
Calls main has any arguments that it has and the contain string.
Okay. Ooh, and the contain string. I like that. Okay, so maybe there's a couple of them. Let's see. I'm going to turn this into a method called no, just invoke student main. Yes, I would. Oh, so you see what IntelliJ did here? He's it's like oh, I saw that actually. No, you probably didn't because I didn't explain to you. Sorry. That's when you gotta be like, Dave, what the hell did you just do? Okay, so I selected it. Here again, another expression. And I went under refactor and I said extract method this time, which is Command Option M. So it says, hey, take that expression and turn it into a method. So this creates it says, oh, okay, you're going to create a method. What do you want that method to be called? I'm going to call it invoke student main. So it invokes the main method of student. Maybe it should just be called invoke main method of student. I don't know. What do you guys think? What's a better name? Does invoke student main, is that okay? Seems a little shorter. You understood what I mean? Okay. Invoke student main. And it says, IDEA has detected 2 code fragments in this file that can be replaced with a call to extract a method. Would you like to review and replace them? It's like, oh, okay, there are other places in my program that are doing the same thing. Do you want to turn that into a call to that same method they extracted? Yes. Yes, I'll do that one, and I'll do that one too. Okay, so it created this invoke student main method, which just takes student.class. Okay, that's pretty cool. I've done that refactoring. Let me run my tests again. Does everything still work? Good. Now, like here, I invoke main. I have another invoke main of student, but now I have an argument. And I think what I want to do is I want to replace this with another call to with like the same method. So what I'm going to do is I'm going to introduce a parameter to invoke student main. So I'm going to say refactor and rename change signature. I'm going to add a parameter, and I'm going to call it it's going to be type of string. Dot dot dot. So dot 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 is variable length arguments like var args in C, and I'm going to call it args. So now it gives you a little preview of what it's going to look like down here. That's neat. Refactor. Okay, it's all happy. And notice I introduced it, but I never use it, so I'm going to then use it here. And now I can just change this into invoke student main with fail. Okay, so let's see if this works. Yep, everything's still good. Now I think you suggested one more, right? You assert that, like really, so like the whole body here, it's like becomes one big method.
Yeah, so you can call that one method with your args and
Yeah.
contain string.
Turn this into a variable, and I'm going to call it error message. Yeah, like that. If I could type, I could. Let's see here. Oops. Rename error message. Move that up a line. I'm going to say, okay, just these two. Now make a method with these two. Again, the command alt or command option M. And let's see here. What should we call the method that does here? It's like assert that standard error contains this error message. Again, it found some duplicates. Say what? So I replaced it here and here. How come I didn't get these two though? Oh, this is the method right there. So that's not a test method. Let's see here. This one. Oh, because it couldn't replace it because of this parameter here. So let's see what we can do about that. Oops. Oh, interesting. It's not letting me. Yeah. So like, it has to be like the second parameter to it. So like if I take this guy, and then I have like that, and I add that there, and then this guy becomes assert that this big mother here error message, and then fail. Well, it works. What do you think? I think I've gone too far. Maybe it's just like the name of this method is just like way too big. Or sorry, the name of this, where'd it go? Yeah, it's what the standard error contains. I mean, that's not so bad. I think it reads much better when this guy's in its own variable.
So we could do like more or less refactoring depending on if you're refactoring actual code versus test code, like, or is it?
That's a good question. You know, the rule of thumb that I follow is that code is code, and that your tests need to be as readable as your production code. Because I think in many respects your tests, well, I mean your tests describe what your code should do. But that being said, yeah, I don't know if we've gone too far here. Well, there's one way to find out. We can keep writing it, and if it gets in our way, we can do some refactorings. Okay, cool. What?
Drunk on the power of refactoring.
That's right. Yeah, it's like, well, it's a very good point. I mean, there are lots of powerful tools here with IntelliJ. You don't have to use them all the time, but let's see where we go. Okay. Oh my gosh. Oh, there's one other refactoring that I wanted to do, and that's like this text which is duplicated. It seems kind of lame to have it in both the test and the student. So here's what I'm going to do. I'm going to do another refactoring, and I'm going to extract a field. Actually, I'm going to extract a constant for this, and I'm just going to call it usage. Oops. I'm not going to call it that. I'm going to call it usage. And let's see here. Now, when I go back to student test, I'm just going to say student.usage. It put it so basically a constant is a static final field. I guess it's not public, doesn't need to be in that class that you extracted it to. So created a constant is just a field that's static and final. Okay. Run it. It's running. It's happy. Okay. Enough. Okay, I'm going to commit this away, and because it's running, so it's like I'm going to upload it to GitHub. What did we do here? Let's see here. Added tests for missing fewer than 6 command line arguments and usage message. Okay, I'm gonna go push that off to GitHub. Yep. Okay, cool. It's now off in GitHub. Okay, let's do one more test case. Let me take a little break or something like that. Okay, so we have usage. Cool. Well, anything else related to like the number of command line arguments that we want to test? Too many? Let's do too many arguments. Okay, what should happen when there are too many arguments?
With the ability to have one or more classes, can you really define too many?
Oh yeah, you're right. Okay, never mind then. So let's see here. When too many, yeah, there isn't too many arguments. Is there anything to test there? Yeah.
It's just a list of strings.
There's a list of strings, right? Yeah, there is an upper bound. Okay, good. Nothing to do there. Nice. Well, do you want to do something like 100 arguments, 10 million arguments? Is that useful?
Well,
Yeah, there's no. It's like.
Maybe what might be a useful test for the future is to just pass it 100 arguments and see if it's fine. Because you don't know if in the future you might tweak something and all of a sudden now you have this like unintended upper limit that you need to fix.
Okay.
So maybe just write a test that you know will pass now, but something might mess with later.
Okay. So let's see here. 1,000 arguments is just fine. Yeah. Okay, so how do we do that? 1,000 arguments, 10,000 maniacs. Okay, yeah. Or actually, what we need to pass it like an array of 1,000 arguments. So we need a string array, 1,000 arguments. Okay, equals new string 1,000 for int I equals 0.
The first couple have to be certain things.
Yeah, I'm gonna mention that, like,
Now do they need to be? Not yet. You're absolutely right. And actually, we don't want 1,000 arguments. We want 1,000 arguments, 1,000 classes. Does it matter right now? Probably not.
Do a check for like one of them GPA. There's a number in there.
Yep. Ah, okay.
So if we just,
Write it down. Let's not get ahead of ourselves. Right. Actually, this is one of the tricks. I think you're starting to see test-driven development is like, oh, but what about this? Oh, but what about that? All of a sudden, and it's really easy then to sort of like have like the big Uber test, and you spend all your time trying to make that pass. So what I would do, what I myself do, is like write it down or post it to the Google community, right? And so that we that we get to it. So yes, that's a good point. Or we can also do this. Yeah. Well, or we can just write. So what's so like GPA?
I think there's a GPA option when you type in the command line, isn't there?
Yeah, I think that's one of the arguments. Okay. Yep. So like we want to make sure that the GPA is a number, is a double.
Yeah, or like
Okay.
it can be.
Oh, so many things. One at a time. One at a time. Okay. And so what I'm going to do is just going to like write like the name of the test, so we remember to come back and do it later. We're not going to get it passing right now. This is super important. Okay. So let's say when GPA is not double, print some error message. Or does it have to, I don't know. Does it have to be a double?
I think it's what it's stored as. Maybe it be converted to a
Double GPA, it's a double. When GPA is not double, print error message. Yeah. Print error message. We don't need lots of details right now, just a reminder. And then wait, you guys had something else? Oh, okay, yeah, right. When GPA is not what's between, well, is, let's just be that, is, what, between 0 and 4.0? Right, that's okay. So when it's less than 0, print error message. And then we're just going to duplicate this with Command D. When GPA is greater than 4, okay. Oops, greater than 4, print error message. Okay, so these tests are reminders that we need to go write stuff. We have some good ideas about stuff. So there is an annotation called @ignore, which let's see here. No, not Nashorn. That you can put on tests to say, oh, yep, don't run it yet. Usually it's like when it's a test that's not passing yet, but these are empty. It's like these don't really count yet. So don't say, hey, everything's passing, because it's really there's nothing there. Okay, cool. Anything else we want to capture before we go back to the one we were working on before? Pop up the stack? Okay. Okay, 1,000 arguments. Okay, so let's create ourselves some arguments. Oops. Tab, there we go. 1,000 arguments. I equals, it's got to be a string, dot value of I, whatever. Okay, and now when we, let's invoke main, invoke student main with 1,000 arguments. We want the value of this guy. What happens? What do we want to assert?
We could just use our class card. We want that to pass, or we want that
Well, what do we want? It's just fine. So actually, it's just fine is kind of isn't very specific. So like when there are 1,000 arguments, what happens? Ones usually mean something bad. So 0? Okay. Exit code is 0. Okay. So we'll assert that result.get exit code equal to 0. Sound good? Yeah, oh, good enough. Okay. We'll go back to run. We'll run our unit tests again. Crunch, 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 crunch. Oh, got a problem. Notice it also had these little like yellow things. These are the ones that are at ignored. But there was actually one that was a problem saying that, okay, it expected 0 but was 1. Oh yeah, because we aren't returning 0. Okay, let's go back to our main method. We always return 1. So what? So if it's less than 6, then we want to exit 1. Otherwise, system.exit 0. Think that'll work? Yeah. Hey, everybody's green. Okay. Time to take a break. I'll commit this back to GitHub. Let's take 10 minutes. And so 7:25 with big hands on 5. Okay, awesome.